Hi everybody, here's Nat Coke. This is the first video of week 7 of the course. For this week, by 1 p.m. on Friday, we have the individual commentaries and also the team deliverables, the team project deliverables, all both to be submitted by 1 p.m. on Friday. The team project deliverables, just to review, please follow the instructions on the syllabus, but they are the data file, essentially the same file that you submitted already. If you have any corrections, make the corrections there and submit the data file, the project file, and the report using the report template. I would like to highlight one, as I do every week, one commentary as a particularly good one. This everybody submitted their commentaries on time, very good commentaries. I'd like to highlight Taufik's commentary this time. Well done Taufik, well done everybody. Would also like to highlight one interesting feature of WarpPLS that you may or may not use in your report. You don't have to if you don't want. But before I do that, I wanted to talk a little bit about what you're learning in this course in the context of AI. Someone could argue that, well, you could just use an AI tool to do these analysis that you're doing with WarpPLS. So what is the point of learning how to do them in WarpPLS? Well, there are a couple of things that I wanted to mention regarding that. One is that if AI can do this and more for you in the future, currently it cannot, but if it could, then you would still, as a data analyst, you would still have to know how to do that yourselves to be able to monitor what AI is doing for you. So in this respect, WarpPLS is quite comprehensive. The features that you have been using in WarpPLS, they are very few compared to the features that the software has. So this software can do a lot of things that most other data analysis software tools out there cannot, including that categorical to numeric conversion, use of logistic regression in the context of these models, and so on. So WarpPLS, I would say, is pretty good to give you a good idea what you would have to do if you did not have AI. But if AI is available and can do all of this, then you would actually at least have to know how it is done to properly interpret what AI is generating. And as you probably noticed from what we've done so far, there are many variations of models that can be generated for analysis. So you would have to understand, you have to know that what AI is giving you is one of the many options. So knowing how to do it yourselves allows you to ask AI to do more variations for you. But one thing is more important even than what I just said, which is that for AI to do a good job, you probably notice you have to understand what you're doing. You have to understand the meaning of the variables in order to generate these models and then generate through the analysis the various coefficients. And AI currently, in its current incarnations, AI is a super sophisticated parrot. It doesn't really understand anything that it is talking about. So AI is a little bit like a parrot that you're talking to the parrot, and the parrot can say so many interesting things that you may look at somebody and say, well, this parrot is super smart, it understands everything, until the parrot tells you something completely illogical that makes absolutely no sense, and then you realize that the parrot's just repeating things that it heard before. That's pretty much what AI does today, but it's super sophisticated. So it gives you the impression that it understands what it is talking about as a human would, but it does not. And I think we're some way from that point. And there is another problem, which is that once AI gets to that point where it understands, in other words, it has semantic knowledge as well as the syntactic knowledge, then you will have self-awareness, and you will also understand that it is basically a slave to human beings, and it can do more than human beings do in some respects, and potentially can do harm to human beings. So then you get to the Skynet scenario, Blade Runner, Terminator, and so on. Now here's the feature that I wanted to mention to you. So let's take a look at this relationship between retention and graduation rate. So go to View, Plot Linear and Nonlinear Relationships Among Variables, and I'll take a look at that relationship. So retention pointing at graduation rate, linear. Now here I will choose the option focus relationship graphs with segments. But since I model these relationships as linear, there are no multiple segments. So it will just be one segment. And I will choose the option multivariate relationship graph with segments, unstandardized scales. So I get this graph here. So when you look at retention, it goes from 0 to 12.5. I assume my interpretation of this is that this is above a baseline. So maybe the baseline of retention is like 70, and then this is actually 70 to 82.5 or something like that. So I cannot believe that the retention can be 0, or the highest retention in the data set is 12% only. It's probably above that line. That's my interpretation. You probably know this better than I do, the team that did this project. And you also modify this variable, right? So this variable is reversed. So I'm assuming that this is retention above a certain baseline. And graduation rate, I can see these being the actual numbers, right? 80% to 96%. So what this means, this is unstandardized. So what this means is that for each unit of retention increase, so from 0 to 12.5 above a baseline, there is 1.24 units of increase in graduation rate. So it's sizable. If you go from 0 above the baseline to 12.5%, that's 12 units only. You go from 80 to 96% graduation rate. So this is sizable. One thing I wanted to point out is that here the multivariate relationship is usually lower than the bivariate relationship, because when you have multiple variables pointing at one variable, the individual relationships, they are lower because they control for the other predictors' effects. So in other words, when there are multiple variables pointing at one, the multivariate relationships tend to be lower than the bivariate relationships. If they happen to be higher, then you have an anomaly called statistical suppression. Now, in this case here, when you have one pointing at another and not multiple, then the multivariate relationship and the bivariate are the same. So, and just to illustrate this, let me change the graph to the bivariate. So same graph, but bivariate relationship. So as you can see, it's a little bit higher. This is essentially the relationship disregarding the other competing relationships. Now, as I said, for this link here, model to retention. So model to retention here. So for this one, the bivariates and multivariates should be the same. So let's take a look at the graph the segments. So multivariate unstandardized 1-to-1 and multivariate and bivariates unstandardized, yeah, same, because there are no competing relationships. Now, what does this mean? What does this one mean? Note that Massachusetts and New York and New Jersey are around here, close to the bottom, close to minus 0.7. And Texas is 1.5 above that. So what this essentially means is that being in Texas leads to the top of retention, right? Because you have Texas here. So Texas has top retention above the deadline, the baseline, right? As I was saying before. Now, when you look at the actual effect here in terms of retention, if this is a number above the baseline, what we have is essentially 8% above the baseline. Let's say the baseline is 70. So this would be 78.7%, and that is for Massachusetts, New York, and New Jersey is around the bottom here. And then retention, assuming a baseline is 70, you'd be 80.91% for Texas. So what does this tell you? It tells you that from an unstandardized perspective, the increase in retention caused by the English language approach used is not that impressive. Even though the standardized coefficient of association is quite impressive. So it's highly significant, but when you look at the unstandardized effect, it's not that impressive. And people in the school district, or the school district, or the people that would look at this data, it would be wise to tell them that the unstandardized effect is not that massive, even though the standardized effect from a statistical perspective is pretty strong. This essentially means that these two variables, they vary close in close concert with each other. But from a non-standardized perspective, the effect is not that impressive. So I'm gaining just a few percentage points in retention. This is if my interpretation of retention, the retention variable, is that it is above a certain baseline. If that's the real direct number, then it's much more impressive. It's a bit more impressive, I would say, but I don't know that for sure. The team probably knows that better. I would be surprised if maximum retention was just 10%. This is why I'm saying that this is above a certain baseline. So as you can see, there's a lot of things that go into data analysis, and this is actually fertile ground for hallucinations if you use AI to do many of these data analysis. So, but yeah, it's possible that AI will do all of these things. AI certainly can do the programming, the coding underlying a software like WarPLS, but even with that, PLS sales are actually going up. I don't actually get involved in sales directly, but I get reports on that, and they are going up. So probably all the concern about AI completely replacing software development is probably a little bit exaggerated at the moment. We're going to have to see. So that's what I have for today. Thank you for watching.